Have you ever wondered why love, a seemingly intangible emotion, can cause such a whirlwind of physical sensations in us? It's a question as old as time, yet it never fails to captivate us. Love, an enigma wrapped in a riddle, has baffled the greatest minds for centuries. It's a profound emotion that transcends the physical, yet leaves tangible effects on our brain. It's an intriguing mystery, a paradox that continues to fascinate us. Join us as we delve into the scientific perspective of love and the profound impact it has on our brain. So what happens in your brain when you fall in love? Well, let's dive into the fascinating world of neurochemistry to find out. The feeling of love, that intoxicating rush of emotions, is essentially a complex interplay of hormones and neurotransmitters. When Cupid's arrow strikes, it sets off a cascade of chemical reactions in your brain. First and foremost, there's dopamine, often referred to as the feel-good hormone. When you're falling in love, dopamine levels surge, giving you that euphoric head-over-heels sensation. It's the same rush you get when you bite into your favorite food or listen to your favorite song. Dopamine is also responsible for that exhilarating feeling of novelty and excitement when you're getting to know someone special. Then we have oxytocin, aptly named the love hormone. This chemical is released during intimate moments, like hugging, touching, or gazing into each other's eyes. Oxytocin deepens feelings of attachment, helping to bond you with your partner. It's also the hormone that fosters a strong sense of trust and safety in a relationship. But let's not forget about vasopressin. This hormone plays a pivotal role in long-term commitment and monogamy. It helps to solidify the bond between partners, creating a sense of connection that goes beyond the initial stages of passion and infatuation. And lastly, there's a bit of adrenaline involved too. This hormone is responsible for the heart-racing, palm-sweating moments when you're around your crush. It's adrenaline that gives you those butterflies in your stomach. But what's fascinating is how these chemicals all work together, creating an intricate dance of emotions. The dopamine makes you feel good, the oxytocin makes you feel attached, the vasopressin makes you feel devoted, and the adrenaline makes it all exciting. So when you're falling head over heels, it's not just an emotional experience, it's a chemical one. Your brain becomes a veritable cocktail bar, mixing up a potent love potion that leaves you feeling elated, attached, and a little bit obsessed with your new flame. In essence, falling in love is akin to a delightful cocktail of hormones swirling around in your brain. Did you know that love progresses through different stages, each with its unique brain chemistry? Let's delve into the fascinating journey of love, beginning with the first stage, lust. This is where our primal instincts kick in, driven by the hormones, testosterone and estrogen in both men and women. These hormones light up the primal areas of the brain, creating a powerful urge for physical closeness or coupling. It's like a chemical cocktail party where our hormones mingle and invite us to take the first step into the dance of love. As we move on to the second stage, attraction, we find ourselves in the throes of intense romantic love. Here, our brains are flooded with a trio of neurotransmitters: dopamine, norepinephrine, and serotonin. Think of dopamine as the reward hormone, giving us that heady rush of pleasure when we're around our beloved. Norepinephrine is like the excitement conductor, keeping our hearts racing and palms sweaty. And serotonin? Well, it's the obsessive-compulsive maestro, keeping our thoughts focused on the object of our affection. During attraction, our brain essentially becomes a love-struck orchestra, playing a symphony of infatuation. Finally, we reach the stage of attachment, where love matures and deepens. This stage is underpinned by two crucial hormones, oxytocin and vasopressin. Oxytocin, often called the cuddle hormone, fosters feelings of deep bonding, trust, and security. It's the glue that holds long-term relationships together. Vasopressin, on the other hand, plays a vital role in long-term commitment, acting like a guard, protecting the bond and keeping the love alive. So there you have it, the three stages of love: lust, attraction, and attachment, all working in harmony to create the beautiful, complex, and sometimes confounding experience we call love. The brain, in its infinite wisdom, orchestrates this dance of hormones and neurotransmitters, leading us on a journey from the first flush of desire through the exhilaration of attraction to the comfort of long-term attachment. From the initial sparks to deep bonding, each stage of love paints a unique picture on the canvas of our brains. But why does our brain react this way to love? Is it merely about romantic novels and fairy tales? Let's delve a bit deeper. Some scientists propose that love is more than just a cultural construct or a whirlwind of emotions. It's a survival mechanism, honed by evolution over millions of years. Love, they suggest, has a practical purpose. It facilitates reproduction, encouraging us to find a mate and carry on our genetic lineage. But it's not just about creating offspring. Love also fosters long-term partnerships, vital for the demanding task of child rearing. Consider the human infant. They're vulnerable and dependent for a much longer period than the offspring of other species. This prolonged helplessness means that human children benefit immensely from the care and protection of both parents. So, the theory goes, love evolved to bind couples together, ensuring that both partners stick around to raise their children. This partnership increases the chances of their offspring surviving and eventually reproducing themselves, passing along their parents' genes. In essence, love acted as a sort of glue, holding families together in a world fraught with dangers. It made us cooperate, sacrifice, and work together for the well-being of our children. The heartache, the joy, the exhilaration, all these intense emotions associated with love may be nature's way of keeping us committed to our relationships and our offspring. So love, in all its emotional depth, might just be a sophisticated survival strategy crafted by evolution. Let's revisit what we've learned about the science of love. It begins with a whirlwind of hormonal activities, setting the stage for what we perceive as the intoxicating feeling of love. There's dopamine, the joy bringer, serotonin, the mood molder, and oxytocin, the cuddle hormone, all working in harmony to create this euphoria. Then we explored the different stages of love, from lust to attraction, and finally attachment. Each stage has its own unique blend of hormones and neurotransmitters, shaping our experiences and emotions. We also pondered over the intriguing notion of love as a survival mechanism, a theory that suggests our ancestors evolved to fall in love to ensure the continuation of our species. It's quite a fascinating perspective, isn't it? So the next time you feel that flutter of love, remember, it's not just your heart that's at play. Your brain, with its intricate network of neurons and hormones, is deeply and beautifully involved too.